Morning, guys. So I'm just going to give you a lecture on projectile motion. So, a projectile, by definition, is an object that is only acted upon by gravity. So no other forces are going to be involved there, just gravity. So we have been looking and we are happy with particular problems where we've got an object that just goes straight up in the air. So say if we have a velocity going straight up in the air like that, you're very happy that the final speed, say if we have a suvat here, sorry, that's just my door, she's not very happy this morning. Say if you have a suvat here, you're very happy that if we've got an initial velocity, the final velocity will be 0, the acceleration will be minus g, because don't forget, the acceleration is always towards the ground. The acceleration due to gravity is always towards the ground. The acceleration is always that way. And then you're happy that you've kind of got three things there and you can just plug them into various suvat equations. And you're happy with that. And we've seen that before. And you've also seen horizontal motion, where you've had like something like a car going along a road and it might be accelerating towards the right like that, with a particular speed v, and then we can again just use suvat equations. So obviously a is going to be equal a, and then u will equal some value, v will equal some value. A bit later, you've used all those before, you understand those. Now projectile motion is a little bit different. So say for example that we have questions like this. So we have questions, say for example an object was at the top of a cliff and it was projected horizontally off the edge of that cliff. It would have some kind of path that goes like that down to the floor. Say if the floor was somewhere here, that's not a nice beach. Now, and we can try and do some physics on these problems. Now, the way that we can do it is that we can actually split this motion. So this projectile motion, this curved motion, we can split the motion into its horizontal and vertical components. So, and what we can do is we can look at problems, like a problem like this, and we can say, well, actually, it's gone a certain a certain vertical distance s, and it's also gone a horizontal distance s. It'll have some velocity, some initial velocity, u in the vertical direction, and it'll have some initial velocity u in the horizontal direction. It'll have a final velocity in the vertical, a final velocity in the horizontal plane. So we said it's got s vertically, s horizontally. It'll have some acceleration in the vertical plane, some acceleration in the horizontal plane, and also it will take some time in the vertical to get to its destination. Some time in the vertical, some time in the horizontal. Now, obviously, this ball, or whatever is being thrown, does not actually split and do its vertical bit and its horizontal bit. It is still one ball, it doesn't actually split. Just mathematically we can do this. So what we know is actually that this t here must be equal to this t here. Otherwise, the vertical part of the ball doesn't arrive at the same time as the horizontal part of the ball. That's just rubbish. So we know that the time it takes to fall, that vertical distance, is the same time it takes to go the horizontal distance. Now this looks a bit complicated. And the way that I like to do it is I like to do a little table, just to make things look a bit neater. So this I call my horizontal, this I call my vertical. I'm trying to smooth that down the side here. That's a bit wonky. Yeah. So, and then I just fill the table in. So in the question I just said there, I said it had a horizontal initial velocity. So this here would be u. Well, if it's only got a horizontal velocity, what is the vertical initial velocity? Well, that has to be 0. The times must be the same, so we can call those t. This is the interesting part. You know that the acceleration in the vertical plane must be equal to minus g. But I'm telling you now that the horizontal acceleration is 0. There is no acceleration in the horizontal direction. And the reason is, if you imagine the surface of the Earth, I know it's very, very slightly curved, but for the purpose of this it's not going to be. Then you've got the gravitational field lines going like that. You'll find more about this in Year 2 physics, but if we've got a particle going that way, perpendicular to the field lines, there's no way those field lines can actually have an influence on the velocity of the particle in the horizontal plane. So the horizontal velocity does not change, so there's no acceleration. So actually, going back to our table here, these two values are going to be the same. U equals V in the horizontal. So before we've even started, before we've even looked at any question, we can do a lot of maths and a lot of physics in there to make our lives a lot easier. So it looks like it's a really, really difficult situation, but actually it's quite easy. So just a quick word on how to apply horizontal and vertical, the horizontal and vertical nature of a problem. All you need is 3 things in either of them, and you can do them. So the Suvat equations, I'll call them the Suvat equations. They hold, which means they work, in vertical plane and separately in the horizontal. So, right. How does this actually look? Well, let's just do a worked example, shall we? Let's do the worked example from the book, just so I can talk you through it. So, an object is projected horizontally at a speed of 15 meters per second. So, let me just write this worked example. So this is on page 133 in the book. So, an object is projected horizontally at a speed of 15 meters per second. That was my doorbell, so I'm just going to go and get that. I do apologise. Okay guys, welcome back. So, sorry about that. Work example, an object is projected horizontally at a speed of 15 meters per second from the top of a tower of height 35 meters. And we've got to calculate how long it takes to hit the floor, hit the ground. How far it goes horizontally, and the speed just before it hits the ground. Now, I don't really like wordy questions, so I like a diagram, and then I like sorting it out from there. So we've got our tower, and how high is the tower? 35 meters, and V is horizontal only at 15 meters per second. So now what can we do? Well, it's not a lot of information, but it's enough. So let's write our SUVAT, S-U-V-A-N-T, and got our horizontal and our vertical. And let's see what we've got. So horizontally, we know that the velocity is 15. That's a good place to start. And we know that the final velocity will be 15 because the acceleration is 0. So we can do that straight away. We don't know how far it goes yet. So we haven't got this yet. We don't know the time yet, so we can't do anything more than that. Vertically, well, we know it starts at a vertical speed of 0. We know the acceleration, and we can pick our positive direction here. But let's go, I'm going to say positive is downwards in the vertical plane, and I'm going to say that right is positive in the horizontal, so acceleration is going to be g. And of course we don't know the final velocity. Oh, we know the height, 35, and we don't know this. Instead of putting zeros, because that's going to be really confusing, I'm just going to put question marks. Confuse myself. Doesn't take much. Now, in the vertical plane, oh, also, just so I don't forget, the t's are equal, so I'll write them like that. So we've got enough in the vertical plane. We've got 3 things. We've got S, U, and A, so we can go ahead and work out t. So we know that S in the vertical plane now, S equals ut plus a half at squared. Well, u is 0, so I can cross that out. And we are looking for t, so we know that 2s over a is going to square rooted is going to equal t. So what's that equal in numbers? Well, 2s is 70, a is 9.81. And that's going to give us an answer. So, and the answer should be about 2.67 seconds. And now what I can do is I can go ahead and write in here 2.67 seconds. 2.67 seconds. Now it's worth noting that I'm using a rounded answer here, so if I use that t again, it's going to be, might give me an error. Well, it might give me more of a rounding error. So that's part A done. Let's look at part B. Part B. How far does it go horizontally? Well, speed equals distance times time. So speed equals distance over time, sorry. So V equals S over T. So S equals V times T horizontally. Because the speed doesn't change, because it's going at 15 meters per second for 2.675 seconds. So we know that S horizontally is going to be 15 multiplied by 2.675. Which is 40 meters. So, and the answer to B is 40 meters, and we can go ahead and put this in. And I'll tell you what up here. And the last question is its speed just before it hits the ground. Now, don't forget, this projectile is going to be coming in at some kind of angle to the ground, right? So we're going to have the vertical speed and the horizontal speed. Well, we know the horizontal final speed is just 15. We need to figure out what the vertical final speed is. So we need to go ahead and figure out this. And I'm only going to use S, U, and A, because if I use T, I'll get a bit more of an error. So, and I'm going to use V squared equals U squared plus 2AS, and where U was 0, just write this, don't forget, U equals 0, A equals G, and S was 35. Now, U is 0, so we can just cross it out straight away. So that makes V equal to 2 times 9.81 times 35 square rooted. And that equals about 26.2. And I would go ahead and put it up here. So now we've got this position here where we've got 26.2, we've got 15, and we want the final velocity. Well, you know it's going to be somewhere here, like the resultant velocity. So let's just kind of do a bit of Pythagoras, and we know that, I mean, if you want to, you can kind of move this over to here, so we kind of get a nice little triangle. So 26.2, 15, and I'm going to call this capital V with a little line. So we know that capital V is going to be equal to 26.2 squared plus 15 squared square rooted. Again, I'm squaring that 26.2, which is a rounded answer, so be careful of, I'm just mindful that I might be a little bit out. That equals about 30.19 or 30.2 meters per second as a final answer. So that completes the lecture for Projectile Motion 1. I hope that you have learned something. Please comment on the video if you want me to go over anything more. Thank you very much.